So hello everyone, welcome back to our channel. This is the another session in which we are building mechanical robot. So in the last session we stopped here where we wanted to fit this motor inside. So hello everyone, welcome back to our channel. This is the another session in which we are building. Yeah, sorry, that was my bad. So what we are trying to achieve here is like somehow connect this motor to the main machines. So let me first show you the motor itself. The good thing is that I have the camera installed now, and yeah. So let me show you the items. We have already printed some of the parts, like this leg is being printed, but we are having some issue. Let me show you this first. One second. Just sharing my desktop, and these are the parts which we have already printed. So this is the leg, one of the leg. So we have printed such 8 legs. Well, it needs to be cleaned, but yeah, because you see there are supports over here. But then there are 3 other items which have been printed. So this is the main side plate, which will hold the gears inside it, but we have a problem, it doesn't rotate. So we may need to redo this with some tolerances so that it can easily rotate inside it. And yeah, most of these are the same parts which we have printed so far. And the quality looks good. The camera is not doing justice to the quality, unfortunately. But yeah, it's actually very bright in color. Looks good. We'll now proceed with the other items. The main gearbox. We will install the drive and all. Let's go back there. Give me a moment, I just need to clean it up. So this motor over here, this we have already purchased a motor. Let's first get the dimensions correct. I did it yesterday, but I think I made a mistake. I didn't set the caliper right. So let's first take the dimensions correct. Let me show you the motor I have. So this is the same motor. I would say similar, not same, but kind of looks good. It's a 12 volt DC motor. So let's see the dimensions we have got. So the diameter is roughly 3 mm. So the diameter is 3, and the total height of it is like 80, and the diameter, so let's correct that first. Diameter is around 37, 80 and 3. Let's correct these dimensions first. So the diameter what we have now is 4 actually. We need to correct that first. And the length of it, what we measured was 80. I think this was not correct. So it's 90 here. So we need to reduce the length of it. So we'll go to the core geometry. So overall length it's right now 87. Let's reduce it to 80. Okay. And the diameter is 3 mm. What we see. So let's correct that also. And so it is 380. The shaft looks a bit longer, so we need to check what is the height of this. Let's go back and measure that. So this is 57 roughly. Let's do that. 57. How much is this right now? This is right now 59.72. So I just need to increase it by 12. Maybe I just need to shorten the shaft length, and that should work. Minus 2 mm. Okay. And last thing is the diameter, which was 37, I think. So the diameter is 37. Let's correct that also. This is 37. Okay, so now we have made it right. Now we can start adding it into the gearbox, or you can say drive box. This model is kind of okay now. So what we need, so in this generation, or I should say in this version, I'll try to use just one motor, and if that doesn't work, in the next upgrade we will change it. So let's start with that. We will need some plastic gears. So we go to McMaster website. You can find the model from there. Let's see. Gears. I'm looking for like bevel gears. I'm not sure if I think these can work. We can try these. Well, if we do this, there will be no. Let's try bevel gears. Small gear, large gear. So we don't have much of the options right now, unfortunately. But let's see if this works. So it has got like 6 mm face width. Machine is fine, nylon, small gears. For shaft dia 6 mm. Not sure if the 3M model is available. Let's see. I'm not getting into too much of technical part right now. Whatever fits, we can use that. We can definitely increase or decrease the idea of it. Let's see if it works. So what I'm thinking, maybe we should make a separate sub-assembly of this part. We'll select these two and form a new assembly. We use the parent assembly over here. So now, this is right now a virtual assembly. Means it doesn't have a separate assembly file of its own. So what we will do, we will simply save it outside the assembly. So let's call it drive box. Let's call it drive box assembly. And we can call that gear here. Let's call that gear plastic bevel gear here. Well, it looks kind of okay. I'm not sure about the strength, but let's use this. So what I am thinking of is to position this motor. First we need to ground the main casing. Let's fix that. Then we need to fix this as well. I think it should go like this. And I will center, just for now I am centering it, and you can always update. So now we have placed it. Now we can start putting our other components. So there is the plastic here. It is actually inside it. Of course, we need to modify it because the ID doesn't match. That we will do. So, yeah, we go to the part file of it and we'll simply update the ID. It says imported. Doesn't matter, what we'll do is simply make a sketch and let's say 3 mm, and we can convert this also. We get out of this sketch and we extrude it. This up to the surface. So now the dia right now is 3 mm, which is what we wanted. Go back to our drive box. Yeah, the mate failed because the face has lost. We need to do that mate again. So now this is the main driving motor we have. We need to connect it to the adjacent legs assembly. So for that we need to make, we'll need another gear. So let's say if large gear face width. I think previously I took this one, face width. The same I will use the, I'm not sure if, let's see. I could have taken the larger one. Just save it, and now we can call it directly into the dry box assembly. Okay, so we have it here now. Face width is 6 mm. This is comparatively weak. I think we should go for the bigger one. Let's do it again. It will not take much of time, but let's do it again. Let's go with the 8 mm instead. This is the 8 mm level. Let's call it, we'll call it in, I don't remember the name, so I'm getting confused. I'll open it again. Okay, so now we can simply call it here, and this is with 8 mm face width. This looks better. Now we have to download the small gear again. We'll go with this one this time. So now we have this. Let's do the same thing which we did some time back. It's simply convert it. We have to give it a surface, and now it is done. We can call it again. In the gearbox assembly. Okay. So this is slightly better. We had just 2 options available. Well, there are lots of options available in the market, but we just wanted something quick, so we chose this. Now it is kind of good. So we keep a distance, let's say 1 mm or even 2 mm is fine. It's just that it should not collide with something. So now on this gear, so this gear we have to modify, but it doesn't have anything to mount, so we need to modify it. Let's just do that. And simply first fill the center hole. We don't need that hole. I should remove that, otherwise it will cause some issues with the 3D printing. Corridor. Now it is gone. What thinking maybe we just need to make a plastic shafts. So right now the diameter of it is 32 mm, which is good, really good. And when we look at it in the main assembly, we see it like this. Something has failed. Yes, because we made a separate assembly. Okay. Now this looks right. So this gear has to be connected with this one somehow. So what I'm thinking, maybe we just do a hex shaft. We should connect to it. First we'll do a round shaft so that it gets hold of it. Yeah, right. I'm just thinking of the solutions. Let's say it's 25. Let's keep it 10 for now, and we can always edit it. Do another hole. And let's say 20, or maybe just 15 is fine. Extrude it, give it some dimension, say 25. Now we go back to our geared assembly, dry box assembly. Now we have to find a place to mount it. So we need to do some holes in this. And this is very weak right now. I think we should give it a thickness of at least 5 mm. I would say 10 mm. Just give it 10 mm. Now we have to place it inside its 2 certain holes. I don't have anything ready-made on my hand, ready-made sketch, so I'm doing live decisions. Hope it works out. It will, sure. I'm straining it at the mid point. And this we can say 20 mm. And this dimension we can add 30. Add it, extrude cut, and give it through all. Now we have to assemble it. We can do the minor adjustment later also. I'm just doing it so that we can do the placements correct first. This is not engaging right now, we can always come back and edit it. Let's first put the things in the right place. stuck. Okay. So I have given some step here so that something's there to stop. It doesn't go in and out. Now we have to iterate it. So what we see is there's a lot of gap, so we will just adjust it. First, I think we need to adjust this 40. And now we have to shrink this up. We don't need so much of the gap. We can do certain measurements also. Let's do it like this. Still not engaged. It has to be fine-tuned. When there is a different, the PCD should match, so that is all together a different work. So I'm just doing what looks right, and I think this should work. The centers are still a bit away. Okay, there's one more thing. This is not yet fixed. We have to fix this as well. We have to make some kind of fixture which can hold this up. And to put this in, I think best is we fix these two and we push this from this side. I think that is the best way to do it. You can also drop it from the top, but I believe it's best we push it from this side. For that, we need to do certain casing here. Okay, let's do that. So I'll open the part, I'll do a sketch. First thing, okay. Okay, or let's do the other way around. Let's do. So the OD of that motor was 37, 38. I'm doing it 38. Let's constrain it in the centers. It's not necessary, but okay. When we do an extrude cut, and we are clear with it. Now we go back to the assembly, and we see now we are able to push this thing there. Yeah. So I don't think we'll need this much of length, so we can reduce it. I'll do it 100. And maybe we need to thicken this face so that the motor can be. And the good thing is that we can actually fine tune this. Once we print this out, we can actually fine tune this so that it meshes properly. So what I'll do, So I'll simply move this face, say 20 mm. Let's fix this also, it keeps rotating. Now it is fixed. This we can adjust, this we can fine tune, but once it's fixed, we need to see it doesn't go anywhere. Yeah. What we can do, I'm just thinking what we can do here. I think we need a stopping face also, because there's nothing which is stopping it to move from moving it in this direction. And what I see from the motor I have in hand, let me show you. So we have got like these two tapped holes over here. One is there and one is here. So somehow we need to use this to fix this motor in place. Other than this, we don't have any other way to fix this up. So we may need to do some, and we should not be clogging this, should not be covering these holes. These are required for the cooling. So we need to make something which fits around it without obstructing these. Let's do it. So now we go back here, we open it up, and we give it a certain step against which the motor will stop. The only problem is that we can't have it too much, but we can have something. Let's give it a 2 mm step, I think that should be enough. Convert this as well. So this should be able to hold this in its place so that it doesn't come out, and we have to give certain projections So what we see in the motor, these are like 180 degrees apart, these two holes. So we can use that. Sketch. Just fixing these up. It is still not fixed for some reason. Yeah. Just do it the other way. We'll extrude it up to the surface. Now we have these two notches into which we can do the hole which matches the motor holes. And we go back and see if it fits. Now we have to like stop this against this wall. We can increase this notch. Well, this is not the real motor, so I will measure it and we'll update it next. So this is what we have. I think we can measure it right away. So the holes are like 22.8, but these are like kind of the ends. So the center would be, I would say, 22. So it is for M2, I think. Yeah. Good. Just measuring it again. It's 22. Yeah. So okay, I think we can reduce the diameter to 22. 22. Now we see it kinds of okay. just need to adjust it so that it engages. I'm still not very happy with this thing. Maybe I need to do something else. This may be an obstruction also. I really feel I had that motor in 3D, but I'm just being lazy not to do it properly. Let's see. So these are like 27. Let's adjust these holes itself. We don't need the threads, you can suppress this. You just need 2 of the holes. I shouldn't have done that. Let's call it back. I'm just okay, let's leave it like that, and then we'll just adjust the center distance of these 2 holes. Give me a second, I just need to snooze my alarm. Yeah, I think we need to first get this right before, but let's do the concept first so that it is, these fine tuning we can do at the later stages, so that at least we are through with the concept. Too much. Needs to be fine tuned, certainly. Maybe 85. Work better. Let's do 87. This looks much better. Maybe we are colliding here, so increase it slightly, 92. This, it looks like this will work. I think I need to do that gear calculation thing so that we can see what should be the exact distances. I'll do the next step maybe in the next session. So yeah, now we go back to our main assembly and see how it is coming along. Yeah. So this needs to be improved. The mate is not correct, so this mate will not work now. So this has to be centered with the gears itself. And another mate was there, this one also we can delete now. So now we can simply give this a center to it. So now this is done, and it will revolve because we have lost that mate. We'll just give it a parallel mate. So this is the basic shape of it. It looks like it will work, and it will work. Now we have to put, we have to connect these two. Right now it's just disconnected. If I make it transparent, you'll see. So these two have to be connected somehow, like this shaft, and these two have to be connected somehow. Yeah. That part, I think we are almost 45-50 minutes completed. This may take like some sessions. It's not a quick job to do, but yeah, we are close. So yeah, let's do it in the next session. See, I'm doing it like really in very real time. I have no preparation. I'm thinking as we are doing it. So this may sound like it is taking some time, but this is how actual real designing happens. In tutorial, what we do, we just trim away the thinking part and the real time involved, and just a fast forward of what we have done. So, but if somebody is actually interested to see how much time it takes and what are the steps, like we also go wrong and then we have to go right, get right. So like that's always what we have to do. So this is always a part and parcel of that this design process. But yeah, this is always a part of it. Yeah, okay. So I think I take leave from you, and we'll continue in the next session. Just a very humble request. If you think that I should continue these kind of sessions, please leave some likes. And if you think it's just a waste of time, just leave your comment also. But either even if you dislike it, or if you want me to improve anything, I'm not. Our channel is very old, but I'm not very used to this kind of live sessions. And like most of the designers, I could be wrong, but I think most of the designers speak less and like think more. So same is with me. But let's see. I hope it goes well. And if you get anything out of it, please leave a like. That will actually motivate me. I know that very few people are watching it right now, but maybe at a later, whenever you see it, and if you think we should continue this type of live sessions, please leave a comment or just a like. I would say even if I get 50 likes on it, that will be very motivating for me, and we can quickly jump on the next phase of it. Anyway, and I really want to see this thing moving, and once this is done, we can also bring up the next generations and maybe some other kind of machines like that. So that's all for now. See you in the next session. Bye bye.